Hi, I'm Cheuk, and I'm going to talk about how to be Pythonic and my journey of designing a query language in Python. So these are my contact details. Feel free to follow me on social medias. So I'm Cheuk. Who am I? I actually love open source projects. I have been involved in different open source projects in my life before, mainly in Python. Currently, I work full-time for TerminusDB, which is an open source graph database. I also love organizing community events, from conferences to, meetups before the pandemic, and also sprints that people just contribute to open source together. Right now, because we are going nowhere, I also do streaming online on Twitch. Yeah, so if you follow me on Twitch, sometimes you will catch me online doing some Python stuff. So one question that I always ask is like, what is Pythonic? Because you have hear this like many times, people talking about it. So what is Pythonic? What does Pythonic mean? So I found this answer from Stack Overflow. Obviously, someone's asking the same question. So it says Pythonic means that the code it's not just that the syntax is right. Well, it means that the code is correct, it runs, but usually there's like more than one way of doing it, right? So if it's done in a way that is accepted by the Python community, that is easy to understand code and what the language is intended to be used, then it's Pythonic. So in my mind, I think that, okay, so it's kind of like artistic thing, right? So it's first subjective, whether something is beautiful or something is better is subjective. How do I know like what is Pythonic, what is not? So I think a lot of things that come down will be like looking at what other people approach it, or sometimes it's just that if there's less line of code, or to check whether you follow the Zen of Python. So in case you don't know what is Zen of Python, try doing import this in a Python terminal. Then you'll see the Zen of Python. Yeah, so it's something that it's kind of like you learn by doing it. You learn by looking, like maybe contribute to open source, or you learn by just, reading other people's code. One example is that Pandas. Pandas basically is like its own ecosystem. So a lot of times when I browse Stack Overflow, people ask question about Pandas, how to do this, how to do that. A lot of times when I first learned how to use Pandas, I was like, why I can't just use a for loop over the data frame row by row and find the answers? Instead, I have to do like aggregation, joining, and all this stuff. Why do I do it that way? Well, the answer is that, because Pandas, it kind of built on NumPy, and then NumPy is a library that, if you use the built-in function, that it's optimized, so it's a lot faster because it uses the C extension of it, so it's like a lot more faster than doing a for loop. So that's very, practical advantage of doing it. It's not just the style, it's not just beautiful and people love reading your code, it's also for performance. So if you use Python in a way that is what is intended to be used, then there's benefit to it. So for example, for loop, again, we all love for loop. Well, this is not Python code, obvious. I hope it's obvious to you. So it's a JavaScript code, or JavaScript, kind of like that. I forgot where I copied this from. So it's actually something that I learned when I was in school, like to use the index and then increment the index so you access all the items in an array one by one. But in Python, things are much simpler. You just use I would be, you just care about what's inside a list, for example. So you just like find all the items inside the list and then you just do whatever. Or even sometimes it's more compact, right? It's like list comprehension, all this stuff. So usually like Pythonic way is actually a simpler way. So things is just like less code is simpler. Usually it's a good indicator of things that, things are doing it Pythonic. A lot of times, especially when I'm doing when I was developing the TerminusDB Python client, a lot of the work is translating, the code from JavaScript to Python. Then I have to think about, okay, so how should I do it in Python? It should not be, like a for loop. I shouldn't be like writing it, incrementing the index instead, but I should care about the items in it instead, because that's Pythonic. So I mentioned a little bit about working on the Python client of TerminusDB. So yeah, my journey of all this like thinking about how to design a Python client started when I became a developer advocate of TerminusDB. But before I tell you my journey, I have to maybe give you some idea of what TerminusDB is, right? It's a graph database. So some of you may already have experience with graph database. For example, Neo4j is a very popular one that is much more of a history and is more well known. We are also a graph database, but of course different. But to make things short, imagine that you're not storing things in a tabular format. So this is how I used to store data when I was a data scientist. You know, lots of CSVs, lots of SQL databases. Things are stored in tables with a index, a key, key on the left hand side there. You see person ID is the key there, the primary key. And you have some information about this person, obviously name, date of birth. And okay, so mother and father, there's 2 columns there. That is some of them are null and some of them got some number in it. So what are they? I hope at this point you already figured it out. It takes a while to make sense out of it. And then you can imagine that it's actually a family tree. So if you put the information not in a tabular format, but in a graph format, it kind of looks like that. And it's very obvious for you that it's a family tree because, well, we named the edge mother and father. So you see that, it's mother and father. Of course, your parents is a family tree. And also, you can obviously see who are the grandparents, which person and which person are in the same generation. So all of these very obvious. If we put it in a graph format instead of this, you have to think about, okay, mother and father actually is a key to join back to the person. So then who is the mother, who is the father? Then you have to make some joins. We do a lot of joins when working with SQL. So yeah, like sometimes, the data itself is more natural to present it in a graph format. So that's why graph database is kind of useful. Again, like this is how we find the maternal grandmother of John with SQL. You have to, select from a table and then, do some joins, maybe join it back together. I'm not a big fan of doing that, like awkward aggregation and then joining tables together. Yeah, I just found it quite difficult to think it in my mind. Instead, with TerminusDB, we have a query language called WOQL. So in WOQL, it's very similar to Prolog, if you know what Prolog is. So it's kind of like you making statements, logical statements, and then you just find which variables kind of suited those logical statements. So you can see here that we will have 4 triples, which is those relations, 2 nodes and an edge is a triple, and then we have a person. So actually, like you want to find, like, for example, the grandmother of John, then you will put John here, and then you will find like, oh, there's this person should satisfy this relationship, which is like John's mother, and then the other relationship here will be like the mother of the mother will be the grandmother, maternal grandmother. So here, like, you can find a variable that satisfy these relations and give the name of those people. So you have the name of the mother and the maternal grandmother in this query. So everything is just done in one place instead of making multiple select and join statements. So yeah, like here you can see that we need 1 and 2 statements to find mother and grandmother, right? And then here you can just find all of them in one go. It takes some time to get around how you think about you query the language, but actually if it works, then it's much more efficient. So this is WOQL, right? This is the query language of TerminusDB. And then when I first joined, there wasn't any Python client. WOQL was natively a JSON-LD. This is the JSON format is what the front end talk to the back end, what the clients talk to the server itself. So WOQL, the native format is a JSON-LD format. And at the point that when I joined, we have JavaScript client. So I think that, okay, so if we want to help Pythonistas and data scientists to use this awesome graph database, we need a Python client. So we have WOQLpy, a query language for Python users. Great. And so I got support from my team and everybody think it's a good idea. So we start working on WOQLpy. So what is WOQLpy? Well, it comes with the Python client, obviously, which you can pip install. It's on PyPI, release on PyPI, like all other Python libraries. it includes multiple modules. So it includes the Python client itself, which is kind of like a wrapper for the API that you could carry out different manipulations to the server database. There is also the WOQLpy, the query part, WOQL query. So that's how you can build your schema, how you can query your data, how you can insert the data in the database. So that's the second bit. The third bit is that there's a visualization tools that could give you an interactive graph visualization of your results data. So I'll talk about that later. There's also this data frame, which is an optional module. If you install, then you could use some of the functions inside to convert your result from a JSON format into a pandas data frame, which is quite cool. So this is an example of how to use TerminusDB. Here in this example, we are building a schema for this bike data. So you can see that we have like three objects that we created in the schema graph. So it's a station, which is a document type. So there is also like label and description of it. You can also add property, for example, like the journey data type, you can add property to it. So you can imagine all of these actually describe, for example, I have a station object, then I would have, well, it would have a, have a name, it will have a label, a description. If it's a journey object, on top of those, you will also have these properties, right? You also have the end time, start time, the journey bicycle, and all these properties. So this is a schema. You can also add them all together. So I have created 3 different type of object, and the schema consists of these 3 types of objects. So just add them together and then execute it with the Python client. It's still not the most optimal way of doing it. You still have to make a lot of method calls on the WOQL query object. But I'll show you a better schema building design that we have just come up with that is still under development. I show you this first because this is what is being used currently. But originally, like I said before, WOQL is actually a JSON format natively. So yeah, you can use the Python client, but like if you don't use WOQLpy, you have to write the query like this, right? So obviously people don't want to write a query like this. They would rather do this, with all the Python code, or even better, when I show you the newest Python schema building regime, I would say, I don't know how to describe that, like the scheme for building a schema. Yeah, so also we have some flexibility in our query objects that you could design your document type by chaining the extras like label and description, or you can just put it in as a optional variable. So you could do that because these two are quite optional. So you could put it in like this, or just like chain it up, so both will work. So there's some flexibility in the design, but there's also challenge when I try to translate the JavaScript one into Python. For example, the method and in Python, some of you may know that and because it's a keyword, it can't be used as a method name. So it can't be directly translated as the same as the JavaScript. So you have to use WOQL, which is not a very good name. So that's why now we have overloaded with the operator. You can see the plus sign that I've shown you before. Also, right now for the OR, we also have the pipe operator to be used as OR. For not, also a keyword, you can't use it. As and from, you can't just use it as it, because it's, again, like it's a keyword. So now you have to add the WOQL underscore prefix to it, but we may change the design in the future. You never know. This is about the extras, things that we flowed in for the Python client. So this one is the integration with Jupyter Notebook. So we have a few things that make data scientists who use Jupyter Notebook have a better experience. For example, like I mentioned before, there's this data frame module that lets you convert the result into a pandas data frame. And also this one is the interactive graph visualization that I mentioned. So you can see that all of these are customizable. You can change the color of the node. You can change the size of the graph, and so yeah, there are different ways of visualizing your result in Jupyter Notebook, which is quite nice. So it's not just Jupyter Notebook. You can actually output this as an HTML file as well, because it's just use D3 to generate it. I have another talk about how I make this part of the Python client happen, but I don't have time for this talk. We're mainly focusing on the query language. So yeah, but I think you can find my previous talk in YouTube or something. It's recorded. This is something new. So this is the schema builder that I talk about. So remember before, if we have to build a schema, we have to use the doc type thing here, like this example here, that we have to use the doc type and then add the property to the doc type, right? And we just think that it's not intuitive enough for Pythonistas. So actually we kind of use like more like a data modeling approach that you could use class, and then it could be, so everything would be a subclass of object or document or enum. Actually, I'm still working on enum thing. So you can have all the properties as its attribute, and then you can use annotation to fix the type of the property. So whether it's like a data type property, like a float or string, or it could be an object property, like, you know, for example, country, then I can have the parameters, like I'm using coordinate, which is an object that I just like an object type that I just created. So yeah, so this is what we are moving forward to. Right now it's under development. Also, instead of setting the label, the description, it will just use the name as the label. Description will be the doc string if there's any. So yeah, this is what we are working on right now. So I hope that is a good design. I hope you like it. So let me know whether you found this is a better way to build a schema. Look into the future, what we still want to do, but not quite there yet. We just want to make life much more easier for Pandas user. Now we can output the results back in the data frame format, but the other way around is not there yet. Hopefully in the future, if you have some CSV, things will be more automated. If it's simple enough that we could look at just CSV or data frame and then kind of create a schema automatically and then input all the data from your CSVs or data frames automatically. That's something that we are aiming for after the schema builder is finished. Also the network graph analysis, I know that, you know, Neo4j has it, we don't have it yet, but it's something that I really want to do, but we don't know when we're gonna have this. If you want to work on this, please let me know. I'm happy to collaborate with you. Also the schema checker is something that, since we have the schema builder like this, so when we add the object in, so all the objects, the data adding in will be a object of these classes, right? So we can actually efficiently check whether the data follow the schema correctly. Right now, the challenge is that when people get an error when they insert the data, they don't know what's going on. They don't know what's went wrong, that they can't insert the data. But with the schema checker, it's kind of like a linter for the schema that you can see that, oh, which part that make it wrong, maybe the type of your data doesn't match the type that is described in the schema. It should raise a flag to tell you exactly which point is wrong, that you should fix it, rather than just pure guessing. So yeah, your suggestions are always welcome. So if you have any questions or suggestions, feel free to leave an issue in our repo. So it's it's TerminusDB/TerminusDB client-Python. I'll show you the link later. Yeah, so that's basically everything that I want to talk about in this talk. There's more to explore, of course, if you're interested in how we created the Python client, how to create the WOQLpy, the query language. If you want to learn more about how to do like graph data modeling, we have the TerminusDB Academy. We would planning to organize more workshops for people to learn how to do the model building, use the new model builder tools and all this. Also follow us on Twitter. You will get all the news. Check out our website, or what is better, join the Discord server. We have office hour every week, which you can talk with the tech team directly, ask questions, give suggestions, feedback, whatever you like. Just hang out with us. Yeah, we want to hear from you. So our GitHub repo is here at GitHub, and then /TerminusDB/TerminusDB client Python here. So you can see it's here. This is a repo. So feel free to open an issue, just suggest anything. So yeah, that's it for my talk. And thank you so much for listening. And feel free to ask any questions. Join the Discord server. I'll see you there. Bye.